Hey guys, Mrs. Ratsberg here. I am just going to be going over some of the properties and some of the kind of requirements for how many triangles can be made given certain conditions, given certain information. And so we've talked about if it's given side lengths or given angles and how many triangles can be made given that information. So first we're going to talk about what information or properties, but I like to think of it more of like what information do we have to be given to make just one unique triangle, so exactly one triangle. And if you recall, that's when we were using those poly strips on the computer together, and we were able to spin the triangle around. So even though sometimes it might have looked like a different triangle, it still was the same triangle. And the requirements that we learned was that the sum, so adding, it's an answer to an adding problem, of the two shorter side lengths must be greater than the longest side. And so an example of that would be like 7, 5, and 4. So 7 is clearly the longest of those three, but then let me change the color. 5 plus 4 is, when you add those two together, you get 9, which is bigger than 7. So it would look kind of like this. So did not mean to use orange yet. I'm sorry, I need green. So like if this is my 7, then my two shorter side lengths of like 5 and 4 would be like that. So that's how we get that area in the middle, is because those two side lengths are bigger than the 7. So like they have to meet up higher up. Okay, so next, I'll use a different color completely. Let's use blue. So what are the properties, or what are the requirements to have more than one triangle? And what we found in the pictures that we looked at on Monday or yesterday, we realized that if the sum of your three angles, so I'm going to start writing that, the sum of the three angles must be 180 degrees. And we saw that there were two triangles with the exact same angle measurements, but they had different side lengths. They were actually what are called similar triangles because of that reason, but you can make more than one triangle. Just think about equilateral triangles, right? Like I could have an equilateral triangle, all angles of 60. I don't even think I can write them all down, but we could have like all the side lengths of 2, or, so all my angles are 60 again, and this time all my side lengths are 3. Same angle, 60 plus 60 plus 60 equals 180, but two different triangles. So if you're given three angles, like for instance, like 57 degrees, 63 degrees, and 60 degrees, that would make more than one triangle because the sum was 180 and it's all angles, so we could make multiple triangles. So that would be more than one triangle. All right, and finally, let's do another color. Let's do pink. What about properties or requirements or information given that would give no triangle? So clearly, just to go off of the blue of more than one triangle, one way to not make a triangle is that the sum of the three angles is not 180 degrees. So it doesn't have to be it could be less than 180, greater than 180, it doesn't matter. If it's not exactly 180 degrees, it will not make a triangle. The endpoints would not connect. It just wouldn't work. I would show you right now, but that wonderful tool is not available to us using on iPads, which is super frustrating. There is another way that we can't make a triangle, which we figured out when we were talking about side lengths, right? So what we found, and there were two different things that we found that could happen. So if the sum or that adding of the two shorter side lengths is equal to or less than the longest side. And I'm going to show you what that would mean. All right, so I'm going to go down and I'm going to kind of like highlight. Whoops, that's not highlighting orange. So if we're equal to, remember what that would look like? One of my classes said it kind of looked like a popsicle. But if we were given side lengths of like 2, that's too light. We can't do that. 2, 3, and 5. That would mean, so we would have this 5 here. But then if 2, oh goodness gracious me, I'm just struggling, guys, I'm sorry. 2 would be like part of the 5, and then the 3 would be the other part. So even if we had connections at the end, when that yellow and orange line went down, it would just form the same length of the line segment as that 5. So it becomes kind of like a drawbridge type situation where the cars could safely cross. The other situation would be, don't use yellow, Mrs. Ratsburg, is if the two shortest side lengths are less, would they add up to less than the longest side length? So if we had side lengths of, let's say 9, let's use 2 and 3 again. 2 and 3, our longest side length would be that 9. But then let me do some highlighting so we can use orange as 3 again and yellow as 2. What would happen is that like my 2 would be like here, and I'll write it in blue as well so you can see that. And then my orange would be a little longer, and that would be 3. This is what I call the T-Rex attempt of a triangle. If the T-Rex's chest was broader and wider, like he would never be able to clap because his arms are so short that they can't reach. And that's the same case here. If we were to lower these down, what we would see is that we would have some leftover space. So if this became a bridge, the poor drivers driving across would never, they would reach like the ocean, on a river or whatever beneath, because they wouldn't be able to cross because the side lengths, the two shorter side lengths don't even touch. They're just way too short. So those are the requirements for those 3. So for a unique triangle, more than one triangle, or no triangle. And you will need to be able to answer those questions on our assessment tomorrow or the following day, depending on, tomorrow. So just make sure that you are ready for that. And now go and take the quizzes to help you make sure you really understand these 3 different types situations. All right, and please let your math teacher know if you have any questions at all. Have a great day. Bye-bye.